today our task is to sum up 50 very small fractions. And just one example, let's just say I equals 4. And I'm just going to write down one of the summands. For I equals 4, that would lead to 1 over 4 times 5 times 6, right? 4 times 5 is 20, 6 times 20 is 120. So this fraction, just for I equals 4, would be 1 over 120. And again, without the aid of technology, we want to figure out a way to add up all 50 of numbers that are like this, and many of them much, much smaller than this ith term for I equals 4. So let's look at our approach here. The 2 kind of yields some insight. What's the 2 doing there? Well, this is something that I wouldn't say it's particularly easy to see. The idea is to try to decompose the original, bring the 2 inside by the distributive property. You can bring the 2 inside. All right, and we're going to try to decompose it into 2 different fractions where we can notice a pattern. And you see how this 2 here corresponds. If there was a 3 here, we might try to decompose it into 3. But the 2 turns out to be the more common form for this type of problem, I think. But notice what happens here when you do the arithmetic or the algebra on this. There's an i+1 factor missing, so we have to multiply by an i+2 factor missing right here, so we have to multiply by i+2. And there's an I factor missing right here, so we have to multiply by I. So we get that this is equal to this, okay? Now, so what that does, that suggests that we should equate, since we have the same denominator here as here, which is by design, of course, we should equate m times I+2. M and n are just understood to be integers, of course, although they could, the math will let them be whatever they're going to be, you know, but they're typically integers. Now again, what we've just done is simple find the common denominator step from here to here. We have the same 2 denominators, so that means we need to equate the numerators. Okay, so we'll set this equal to 2. Okay, but this doesn't take much work to see that this would imply that m has to equal to 1. And n has to equal to -1. For everything to vanish and go away, these are the only 2 numbers that get the job done. Okay, m equals 1. You can verify real quickly that everything cancels except for the 2. Okay, so we know that m has to equal to 1 right here, and n has to equal to -1. Okay, now let's see if we can use that. So this is the original problem. We bring the 2 back inside for the reasons disclosed right up here. All right. All right, and you see all we do, folks, is literally replace this summand with the work from our previous step. Okay. This object got replaced with what it's equal to. Now you're saying that makes it look more difficult, but we're going to notice some stuff here. Let's take a look at what this leads to. Okay, let's try it for I equals 1. Right here for I equals 1, you would get 1. You see 1. This would be if you put a 1 right here and a 1 right here. So what do we get? 1/2. 1/2, and then -1/6. Okay, and let me put this in parentheses, folks. Not strictly necessary, but perhaps it'll enhance the readability. Okay. Now, I'll just write down the efforts rather than talk through it. This is for the case I equals 1 right here. So we're trying to discern a pattern here. Now, for I equals 2, you end up with 1/6. And already you can see that these 2 guys are canceling. Now the next term in this parenthesized quantity is -1/12. Okay, let's carry on. Now again, this would be for I equals 2 right here. Okay, now let's keep going. Like that. course, this is I is equal to 3 right here. But notice what we're seeing. It's not too early to notice a pattern. You got minus 1/6 here, plus 1/6. Then you have minus 1/12, plus 1/12, you see? So all that's left is this term and this term, okay? So this pattern will continue all the way out to 50, and I'll just use the customary ellipsis here. Dot, 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 missing terms. Then our very last term for I equals 50 is 1 times 1 over 50 times 51. And no need to even write down what that number is because it's easy to calculate it, but we know that there would be a term before it right here that would cancel it, right? Minus 1, I probably should have written that down, but this see how these first terms, 1/6 is a first term, 1/12 is a first term, they all cancel. That happens all the way out, so this would end up canceling, and all we have left right here is 1 over 51 times 52. Okay, you guys may have seen this. I'm sure you probably have. It's called telescoping. Okay, a lot of stuff cancels. All right, and so that ends up being, we got room here, so that will be equal to 1/2. This 1/2 that you see right here it doesn't have any cancellation going on, and then there's nothing canceling this because we stopped it. We terminated at 50, right? So that we would have 1/2 minus. Now, y'all, when you multiply this out, you get 2652. So this is 1 minus 2652. Okay, like that. And then notice we have 1/2 right here. So to convert this with a common denominator, half of 2652 is 1326. So this would be 1326 minus 1 over 2652 over 2652. That, okay, and so finally we get an answer 1325 over 2652. Okay, and not that it's important, but this number is still a little bit less than 1/2, right? Not that that's important because 2 times 1325 is 2650. So this number is less than 1/2. And I think in a general term, in something like this, is always going to be less than 1/2. I think that's just a more general proof we could show if we wanted to. But anyway, that's the answer. And again, we employed a technique called telescoping series, I guess. All right, so let's come back up here. 1325 over 2652. This is equal to 1325 divided by 2652. And again, I'm not particularly proud of this because the first step is not super well motivated. But we know that trying to add each of these 50 terms up, then multiplying by 2 would be terrible, right? Just like I say, 1/20th, 1 over 1/20th is just the 4th term. Okay, you can imagine you get incredibly small fractions. You have to find common denominator. It would be horrible. In fact, to do by hand, there's no human being that could do it by hand without making a mistake. Okay, you'd have to use technology here. But anyway, this is the solution, and we tried this approach because of the possibility of a simplification. It looks like you're going to more trouble than it's worth, but then once you see that m has to be 1 and n has to equal to -1, you get this decomposition of this fraction, partial fraction, whatever you want to call it, where you get successive canceling terms all the way to the end to where the only 2 survivors are just this first term and this last term. Okay. All right. that does it. Thank you for viewing.